Okay, so what we're going to do is we are going to determine whether the data set represents direct variation, inverse, or neither. So we already talked about how you can decide if it is direct. So the first thing we're going to do is divide y by x, and we're going to see if those ratios are equal. So I'm going to take y, so we're going to see if it's direct first. Okay, so if it's direct, that means if I divide 8 by 6.5, that should equal 4 divided by 13 and a half divided by 104. What do you guys think? Do you have any clue on how this is going to work out? Yeah, Alex, can you explain how you know, like, right away?
Because 8 over 6.5 is more than 1, the rest aren't.
Perfect. Okay, so if you look at this, right, 8 divided by 6.5, can you guys see that's going to be more than 1? Because the number on top is bigger, right? And this is about 1.23. Now, 4 divided by 13, is that going to be bigger than 1? Definitely not, okay? So you're welcome to reason your way through that, and you could just say, all right, those are not equal. This is 1/2 divided by 104. Okay, so that is going to be a very small number. I just rounded that. Okay, so not direct variation. Okay, and good job for recognizing that. That's very good. So for inverse variation, we talked about how we're going to multiply. Okay, we're going to multiply x and y. We're going to see if the products are equal. So 8 times 6.5. And actually, let's do all this in our head, okay? So first, yeah, if you're doing 8 times 6.5, this is what I want you to do. What's 8 times 6? What's 8 times 6? 48, okay. What's 8 times a half, or half of 8? 4. So what's 48 plus 4? 52.
Yeah, Kylie is 4.
Okay, so for this one, let's see if we can do this one without the calculator. So I'd multiply 4 by what number first? 10. And 4 times 10 is? 40. And then I'd multiply 4 times 3, which is? 12. 12 plus 40? 52. And then this is half. So what's half of 104? So do half of 100, half of 4. Add them together. Yay! Okay, so this is inverse variation. Okay, which is what I have here. Okay, so yes, it is inverse variation. So if I had to write the equation, do you guys think that you could write the equation for me?
No.
Yes, you can. Yeah, because what did we just find?
Why?
Yeah, we just found K. That we were given. Remember that when you write the equation, your equation always has what two variables? X and Y. So you can always see your X and your Y. If you wanted to write your equation, this would just be Y equals 52X. Okay, because this is your K. That's your constant. Okay, so then I'm going to give you some time to do B and C. And I know I have to give you the numbers there. Okay, and while you guys are working on that, I'm going to walk around and help you. the inverse either. I had my microphone off, so I'm sorry. So for B, we divided. We got our K value is 6, so it is direct variation, so Y would equal 6 times X. For direct, when we divide, if we have 5/3 and reduce this to 7/3, because they have the same denominator, we can see that the numerators aren't equal, so that won't be equal. And then when we multiply, 3 times 5 is 15. 6 times 14 is definitely going to be way bigger than that. So because it doesn't follow either pattern, it will be neither. Okay, and then let's flip it over to the back. Story problems. Okay, so for the story problems, you might want to have your highlighters out. Or you can underline, but I just think highlighting is a little more fun. You get to bring some color into your notes. Okay, or colored pens or anything like that would be fine. All right, so it says the time T needed to complete a certain race varies inversely as the runner's average speed. So right there, they're setting up for me what my equation is going to be. So I'm going to highlight that. So the time T varies inversely as the speed S. Okay? So what I could do right away just from that sentence is I could write what my equation is going to be. So from there, what they're telling me is T varies inversely as S, so I know that that's going to be my equation. Okay, that T is going to vary inversely as S. Okay, did you guys, were you guys able to do that part without me, you think? You remember inversely is going to be division. Okay, and it says if a runner with an average speed of 8.82 miles an hour completes the race in 2.97 hours, what is the average speed of a runner who completes the race in 3.5 hours? And this is the question that we're trying to answer. What is the average speed of a runner who completes the race in 3.5 hours? Okay, so I know we have to remember back to last week. Seems so far away now. But for step 1, do you guys know what we're going to find first? Find what? K. Find your constant K. Okay, so we already said T equals K over S. So now what we're doing is we're looking for a pair. And I highlighted the pair in blue. So this would be the speed for this given amount of time. So I'm going to plug this in. So the time goes in for T, 2.97 equals K over 8.82. All right, so Gabe, if I'm going to solve that for K, what should I do to both sides? Okay, by what? Good, okay, so I'm going to multiply both sides by 8.82 because on this side, what's happening is you have 8.82 divided by itself, that'll be 1, and then we're going to multiply. Okay, so we're going to do 8.82 times 2.97, and we're going to round this, and I'm going to write this out first, and then so you can see what the rounding is. And because they, I guess they really didn't. We're going to round this to the nearest 100th place. So this would be 26 point. See how this is a 9 and this is a 5? That 5 is going to round this up to what?
1, 2.
Not 1, 2, but 2, 0, right? Okay, so that's going to be your K value. So then T is going to be 26.20 over S. Okay, so this is your equation. Okay, and then for step 2, now we're going to find the average speed of a runner who completes the race in 3.5 hours. So for step 2, we're going to use our equation And 3.5 is the unit of time. So if it's hours, that has to be plugged in for T. Okay, and then now we're gonna solve. Taylor, how are you thinking we're gonna solve this? By what?
26.20.
Okay, if you multiply by 26.20, then this is what you'd have, 26.20 over 1. So you'd have to multiply straight across. Would this undo the 26.20? If you multiplied straight across, you'd have to multiply 26.20 times 26.20, which would actually make the number bigger. So we don't want to multiply by that. There's a couple other strategies you can do. What do you guys think? You don't want to divide because you'll have like 1 over s. What did you say, Alex?
Multiply by s.
Yes, okay, so you can multiply by s. It also might help you guys if you think of this as a proportion. So if you put 3.5 over 1, if you have a proportion, do you guys know how to solve that? Yeah, you cross multiply, right? Okay, so if I'm multiplying by s, what's a good hint to remind us what we have to multiply by? The denominator. So when you're trying to solve, you want to multiply by the denominator. So this is the difference. If I multiply by s, Taylor, see how I have an s on the top and an s on the bottom? So that means that I'm dividing them, and then I'll get 1. On this side, I have 3.5s. So I'm going to divide both sides by 3.5. What'd you get?
7.48.
Okay. And we're going to round to the nearest tenth.
7.5.
Okay. Yeah, because this is what you have, right? So S is about 7.5 or 0.49. Say it again.
Couldn't you just divide in the beginning instead of doing all that?
I can't hear you. Didn't I?
Couldn't you just divide in the beginning instead of doing all of that?
Oh, could you set up a proportion in the beginning?
Yeah.
Yes. Yes, to find that. Your quiz, Marisha, I'll ask you for 2 things. So I'll ask you for the equation and I'll ask you for the answer, which is why I'm making you guys do this now so you don't forget. But yes, you could just do your equation and then you could set up a proportion too. That would be fine. Okay, and example 3, I'm going to give you guys a minute to read over that. Yeah, I think there's some typos in here. Okay, let's do it together. So the change in temperature T says oven on aluminum. It should be an aluminum something.
Yeah, it says later in white.
Oh, thank you. Yeah.
And then the last sentence just doesn't make any sense.
Yeah, it's very possible. I have some edits on my paper. Apparently, I did not change them. So the change in temperature T of an aluminum wire, and I'm going to highlight this. So temperature T varies inversely as its mass M. Okay? So the first thing we can write, and directly as the amount of heat energy E transferred. Okay, so let's write our equation together. Okay? So the change in temperature T of an aluminum wire varies inversely as its mass and directly as the amount of heat energy E transferred. So let's start our equation. Kylie, what's our equation going to start with?
T.
Yep, so T is going to equal. Now it says that it varies inversely as its mass M. Okay, so Joe, what else am I going to put in my equation? Yep, divided by m, okay. And yeah, do you know where the e's going to go? Okay, yeah. So see how it says it's directly as the amount e? So anytime it's direct, it's multiplied, which means it has to go on the top. And there's one other thing I'm missing. Can anybody tell me? Yeah, the k. Where's the k going to go? On the top. Yep, times the e. Okay, so this is like if you had direct, right, it would be t equals k over m. Or sorry, if you had the inverse, which is the first one, t would equal k over m. If you had direct, it'd be k times e. So basically what we're doing is we're taking those two types and we're mashing them together. Okay, any questions for me on the first part on setting up the equation? Okay, and then the next part, it says the temperature of an aluminum wire with a mass of 0.1 kilograms rises 5 degrees Celsius when 450 joules of heat energy must be transferred to an aluminum wire with a mass of 0.2 kilograms. Yeah, okay. The temperature of an aluminum wire with a mass, blah, 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 of heat energy. And then we're going to stop this sentence, add this. Is transferred to this. Okay, so this sentence should be the temperature of an aluminum wire with a mass of 0.1 kilograms rises to 5 degrees Celsius when 450 joules of heat energy is transferred to it. Okay, and then our next sentence should say how much heat energy must be transferred to an aluminum wire with a mass of 2 kilograms to raise its temperature to 20 degrees Celsius. And that'll be our question. And I'm sorry about that. As soon as we're done with this, I'm going to fix this on my computer. Aluminum wire with a mass of 0.2 kilograms to raise its temperature to 20 degrees Celsius. Okay, so then what we're going to do first is we're going to find K. Okay, so then the temperature of an aluminum wire with a mass of 0.1 kilograms. So I'm going to plug that in for the mass. 0.1 rises 5 degrees Celsius. So my temperature is going to be in for T. And that's when 450 joules of heat energy is transferred to it. So this is my equation I'm going to solve for K. Have you guys gotten to a part in your science yet, or you have heard the term joules before?
No.
Okay.
We probably have, but I don't know.
Okay. So joules is just a way that you are measuring the energy. Okay, so the output of energy. So that is the measurement for that. Now, we're trying to solve for K. There's actually a couple different ways you can do this. Grace, what are you thinking? What should we do first?
Multiply by 0.1.
Okay, good. So multiplying by the denominator is an excellent thing to do. Okay, and you can also think of this as cross-multiplying. So when you do multiply by 0.1, actually I think I'll show you cross-multiplying for this just so you have another method than the one above. So we would multiply by 0.1, and if we did that on both sides, we get 5 times 0.1, and then 1 times K450. Okay, so you can set up a proportion and cross multiply. Or you can multiply the denominator, just like Grace said. That was great. Okay, now when you multiply 5 times 0.1, okay, what's 1 times 5? 5. So if you have the 0.1, all you have to do is move that decimal back. So this would be 1/2 or 0.5 equals k times 450. Okay, and then Joe, how are we going to solve for k? Good, okay. And for this one, we're actually going to leave our answer as a fraction. So if this is 0.5, 0.5 is the same thing as what? 1/2. So what I have is 1/2 divided by 450. Okay, now Caitlin, when we're dividing fractions, do you remember what the rule is?
You like flip it and multiply.
Yep, okay, so we're going to flip 450, which means it would be what? Yeah, exactly, 1 over 450. And then when you're multiplying fractions, all you have to do is multiply straight across. So 1 times 1 would be 1. What's 2 times 450? 900. So that's going to be our k value. Okay. And that way we can have an exact answer. So 1 over 900 e divided by m. Okay, and this would be the same thing as e over 900m. All right, and then I'm going to let you guys do step 2. Okay, so if you aren't sure where to start, it says how much heat energy must be transferred. So if we're saying how much heat energy, what variable are we solving for? E. Okay, and then it gives you the mass, and it gives you the temperature. So sometimes all I do is I just organize my information. Okay, and then you can go ahead and plug those in. Okay, and what equation do you guys want to use for this? The first one or the second one? The first one? Okay. So we have 1 over 900 times E over 0.2, and that's going to equal 20. Okay, so Kylie, what do you think we're going to do first for this? Okay, good. So we're going to multiply both sides by 0.2. Then I have 1 over 900E equals 20 times 0.2. And what is it going to be? Good, okay. So 2 times 2 is 4. And then with your decimal, you are just going to get even 4. So I have 1 over 900 times E. Okay, and Petrova, what do you think we do next to solve? So we want to get E by itself. If it's 1 over 900, how can I move that to the other side? Okay, so you can either divide by 1 over 900, which is the same thing as multiplying by what? You can multiply by the reciprocal, right? Petrova, what's the reciprocal of 1 over 900? 900, right? Because then if I multiply, it's like these two are dividing, so I'll get E. And then let's do this without our calculator. What's 9 times 4?
36.
Okay, so this is just going to be 3,600 or 3,600 joules, which is going to be our final answer. Okay, so your 5.1 homework is page 317, numbers 13 through 16, 27 through 31, 44, and 46 through 48. Okay, so make sure you really are given 100% on those story problems. That's usually what people have trouble with on the quiz.